So what are you doing here in Nepal?
I need one of the pieces your father collected.
Oh, okay. Well, I think we're ready to actually start doing the report, though some of you may be angry about that because you like the coding. And I also noticed that this timer here got paused a little bit during the last video, so I ran it up to where it's a more realistic idea of how much I've actually spent. And yeah, we've spent a lot of time before we've even started writing the report. That's normal. All right, let's start. I need a title. Waging war. That seems lame. I'm gonna go back and try to figure out a better title. I also need an introduction. Okay, well, I can tell you right now, this is the world's lamest introduction ever, and I don't like it. But I always end up going back redoing my intro. I just need something to start, so we'll start there and I'll delete it later. I'm going to tell the client what program I used and talk about how I altered the data, mainly how I fixed those errors. Unfortunately, oh, I forgot to start the timer again. Really? That happens so often. Okay, fortunately, it's not going to be hard to fix the errors because I have a list right up here. And I'm trying to use different wording. I removed that row of data and turned the value positive, and I removed that data point. However you want to word it to just explain why I took those out as they were errors. Now I'm going to talk about making the model. Media was curved with a quadratic, missiles was cubed, and then that bow tie shape, which still kind of bugs me. Remember this guy? So I don't want to hide it. I'm going to talk about it. I tried all sorts of interactions, and I did find some interactions, but this is the best model I could make. Now, maybe you did not find any interactions or any cubes or quadratics. This is the time to say, look, I did search for those, and I did not find any, and these are the best residuals I can get, so this is the best model that I can make. Now, I was about to do the prediction equation, but you know what? I want to talk about how all my terms in the model were significant at the 0.05 level, except if you remember my model, the stock value itself did not have a significant p-value. We left it in because of the interaction. So I'm just going to explain that. All right, and so you do not have to follow my order of things. You don't have to put things in the same order. In fact, I kind of like it when I'm grading and I can tell that somebody is not using my report as a template. Like, do things in the order that makes sense to you. Just because I was talking about looking at p-values in the alpha 0.05 level, I have decided I'm just going to mention the variables I took out. So there's the 1, 2, 3, 4, 5, 6 variables that didn't make it in the final model. Okay, final prediction equation. This would be kind of hard, except fortunately, I kind of already did the prediction equation right here, this enemy hat thing. Ugh, I don't like the way it copy-pasted it all. And this right here, that's our code, so that needs to be equals. And then all these hats need to come off of each and every one of these variables. And now I want to make these look more like they are exponents. Why? The answer is I've spent more than 2 hours on this. I'm starting to feel proud of my report, so I'm going to make it look pretty. That's the sort of thing that I probably wouldn't really care about when I was grading. We do have these categorical terrorism variables. So if I'm going to do the equation like this, I need to tell people terror high is 1 if the terrorism level is high, 0 otherwise. Same for medium. Now the client can look at this equation and see how to handle the categorical variables right here. But that's not the only way to do this. So let me just redo the prediction equation for my model is a different way that I could have done this instead, and I'll leave both in the report so that you can see it. And here I have 3 different prediction equations, and none of them have categorical variables, so I don't need to explain how to handle those. It might be hard to see how these are different. I'm going to color these numbers in red. That's where the equations are different, and I might do that for a client too. Just really point out what is the difference between these 3 different prediction equations. All right, I've got a couple things from the summary fit that I want to talk about. That is an error I'm getting because I have squished my picture too small and it's not liking it. So let's fix that. Standard error and the R squared. And it occurs to me that as I talk about the standard error, 52 to 100, like, is that a lot or a little? I wish up here in the intro that I had talked about I should say in the above graph, talk about enemy deaths being, 3,500 range. That way, as I go down here to talk about the error, that's pretty good. We're talking like 3,500, and the R-squared 0.9981, which indicates my predictions have a high degree of accuracy. There's another way to also talk about this. In fact, I'm going to put both on here so that you can see which way you like. And either one of these sentences would work all by themselves. I put in both. This suggests I have a good model, so yay, that makes me excited.